Hi guys. So this video is just hopefully a kind of brief video about Fortran and how to run the code and kind of a little bit about how Fortran syntax works. So let me go ahead and share a code that I'm going to send to you. This code is called ftrap.for, and so basically what it does is it will take a function and integrate it from x initial to x final, just a function of x, using the trapezoidal method. Now there are a lot of numerical integration methods. I guess the trapezoidal method is the simplest. If you want to look it up, you can learn more about it, but it's very simple. It basically just takes, kind of rectangle divisions of the whole curve and adds them up, adds the area of each of them up to get the area under the entire curve approximately. And so let's look at the Fortran code. First of all, I've got a main program, right? Just the first lines here. One thing about Fortran, you have to go 7 lines over and then start typing if you want to type executable code. Any executable code, or you can't have executable code in the first 7 columns here. This implicit double precision statement just defines real and integer variables. So what it's telling or saying is that any variable that starts with A through H or O through Z is double precision real, which means it will calculate out to 16 decimal places. Just a real variable in Fortran only goes out to 8, double precision goes out to 16. But any letters in between here, from I to N, if you have variables that start with those letters, they can be integer values, right? So I have an external command here, which tells me I've got an external function and an external subroutine that the main program is going to use. Now, if I want to make comments, I can just type a C way over here in the first column, and anything after that, right? Fortran knows it's a comment line and will not run it. So I've just got my first comment: define the parameters for the integration, the initial x, the final x, the number of steps or divisions. So the n, when I use it down here, is going to be an integer, and I think I should have n equal to 1,000 here. But you can define any value of n in the way I've written this program, because it will also define a step size, right, or a dx by x final minus x initial over n. So this calculates the step size, kind of the width of each rectangle. Now the next step is to call the itrap subroutine, which does the trapezoidal integration, and returns the integral as s down here. But first, I just called the function itself. So when I write fi equals fun of xi, what it tells me is to go down to this external function and calculate the value of that function for xi equals 0.001, right? So right now I have this function defined as x squared. So in Fortran, to square things, you do this 2 asterisk thing. But you could change, that's where you could change the function that you want to integrate. But it just calls this function, returns to the main program, and goes to the next line. So ff would be the function xf, which is 1. Then I get to the subroutine, which does the integration. So first of all, I've got some input and some output of the subroutine. The input kind of, what it uses is the function fun, and within the itrap subroutine, it calls it f. So you don't need to actually, when you call the subroutine, use the same names, but it's got to be that function you're trying to integrate. Now n is the same in both, but it's the number of divisions. We have xi and xf again, which are x1 and x2 in the subroutine. H, which is dx. Now s is the only thing that's actually returned by this subroutine. You can return more things if you want, depending on what you're trying to do or what subroutine is. But s is the actual value of the integral. right? And so it will come out, and the last thing I do in the main program is I just print these things. I'll print the initial function value, the final function value, the h, and the value of the integral that the subroutine has produced. So just looking at the itrap subroutine is the command here. Now, one thing about Fortran, it's not case sensitive, so I don't need to capitalize anything, but I can, if I want to emphasize things or something. Again, I've got my implicit double precision, I've got my external, it's going to use this external function f, which has been named, it comes into the program as fun, but within the subroutine I can call it f. And what that does is mean that I can use this subroutine for anything, right? I could take it to another program and use it to do trapezoidal integration. Whatever function I want to use, it's called in to that kind of global f type of variable into the subroutine. So maybe I won't go through the details of that trapezoidal integration, but you can look into it more. It's pretty simple. Again, there are other things you can do like Simpson's rule or Gaussian quadrature, which we can use in other programs, or if you're interested, you could try making a code to do that. But either way, what I'd like to do now is go ahead and try to show you, first of all, where to get the code. And I'm going to go ahead and see if I can share that. Not the code, but the actual compiler. Let's see. So hopefully you can see the screen here. I go to openwhatcom.org. There are other Fortran compilers like a new Fortran, GNU Fortran, but this is the one that I use. It's pretty simple and was around for a long time. If you want to download just the compiler itself, hit the download here. And you can see they also have C and C++ compilers. But I want to go to the Windows since that's what I'm using, and I will just click on this, open Whatcom F77, and it will save an executable file to your computer that you can run and actually install the compiler on your computer. So once you've got that all done, I'm not going to go through that because I've already got it installed here. But once I've got that all done, what I can then do is go into my command prompts. Now to get there, you go into your program files on Windows 10, for example, and go to your system, which I'm going to do here. I don't know if I can show it in the screen, but I find my Windows system, and I go to command prompt, and let's see if I can then share that with you. Let's see. So hopefully you can see the command prompt there. Now, my particular ftrap.4 is saved in a file named code. And let's go ahead. Or a folder named code. So what I need to do first here is navigate. Once I've got all the Whatcom compiler downloaded and set up, I'll just navigate to my desktop and then to that folder. And it's a program named ftrap.4. Now to compile the code, I can type WFL 386 ftrap.4. Now, one thing you can also do here, which I haven't done, is you could take that subroutine itrap, put it in its own file, maybe called itrap.4, and you don't have to have it in the main program. It can be in a separate file. And if you do this, it will actually link all those files together and compile them. So you can actually store your code in different files. But since I didn't do that, I'm just going to run WFL 386 ftrap.4. And you can see it will create an executable file called ftrap.exe. Now to run that, I just type in my command prompt line ftrap, and you can see it runs very quickly. It's very fast. So here's my initial value of the function, my final value at x equals 1, my step size, right? I've just cut it into 1,000 divisions. And here's the actual value of the integral. Now, it turns out integral of x squared, right, from 0 to 1 should be about 1/3. Now, I actually went from 0.001. I could make that smaller, so it's a little bit smaller than 1/3, but it's pretty close, so it works pretty well. Now, last thing, if I want to output this code into a file, for example, a lot of programs, what I end up having is a lot of data being output by the program. If I wanted to send this data to a file, all I have to do is type in ftrap and then right arrow, and then I can name whatever file I want it to go to. Maybe call it int.dat. So this will actually print the stuff that you see here in that file. So last thing here, let's go ahead and check and look at that. So I'm going to get rid of this, and we will go and try to share the window again. Hopefully this works to share my windows here. Let's see. I'm not sure if this works, but when I go into, I'm not sure if you can see that. Hopefully you can see that, but there will be a file called int, and if I open that up, you can see the data that was printed to the screen actually output into the file. Okay, so I'm going to stop there. Hopefully that will give you enough to kind of play with that simple trapezoidal integration code. And once you get familiar with that, let me know. We can try to do more complicated programs, but I think it's a good, fairly simple code to start out just learning how to use the Fortran and Fortran